Thanks everyone so much for joining. Good to see some familiar names and faces again. Today we're joined by one of the co-founders of Kaleido, Jim Zhang. He's an extensive contributor to all things enterprise blockchain, former lead architect of Hyperledger Fabric and a maintainer of that open source project. He also works very extensively with all the Ethereum libraries, Geth, Quorum, Hyperledger Besu, and some additional projects underneath the Ethereum and Hyperledger umbrellas. So I'll let Jim share more details about his interaction with those different projects. But we're lucky to have him today. We're going to talk about a very important feature in Ethereum and in all blockchain projects, and it's around key management and transaction signing. We've done a ton of work in Kaleido trying to provide enterprises and end users with a really flexible array of different key management and signing techniques. And Jim's going to walk you through a broad variety of all those techniques, including using accounts that are managed on the node, using externally managed accounts, maybe with a plugin like Metamask, and also using some of our Kaleido managed wallet services that can make your life really easy when you use those in conjunction with some of our middleware features and easy transaction submission layers. So we'll look at managed wallets and even cloud HSM wallets as well. I'm going to skip my typical slides today. If you guys are interested in a Kaleido intro, I'd encourage you to just go ahead and take a peek at some of these former recordings that exist out here. Every single Tech Tuesday and Walkthrough Wednesday is now curated and available on our Kaleido YouTube page. So if you just go ahead and search for Kaleido Blockchain on YouTube, you'll be able to go back in time and look at some of these former talks that we've done. For example, we've looked at hard forks, we've looked at some signing stuff in the past, we've looked at advanced node and environment configurations. All of those are available for you to hopscotch through and grab whatever information that you want. A few additional pieces of admin, and then I'll turn it over to Jim. We recently did a new release of a lot of different features into the platform. You can read about these on kaleido.io. Just go to the resources and go to the blog. You can learn about multi-factor authentication, our new event streams, hard forks, bringing in the Constantinople block, and a lot of other new features that we rolled out into the console. The other thing, we've added some new blogs as well. So if you just go ahead and click the blog link, you can read about our support for on-premise private stack nodes. You can read about all those announcements, and you can read about hard forks, for example. So all of that's available. This will be recorded. We'll share the recording after the talk. And please don't hesitate to use the Q&A or use the chat feature if you do want to ask any questions or if you need additional information. And I have a few slides I'll share at the end, but in the meantime, I think let's go ahead and turn it over to Jim while we have him with us, and let's learn about Kaleido wallets. So I'm going to stop sharing and pass it over to my colleague, Jim.
Hey, thanks, Nick. Hello, everybody. This is Jim. Okay, let me start sharing. Here we go. So I'm one of the co-founders of Kaleido, like Nick said. In fact, Nick and myself were among some of the migrates from IBM that worked in the IBM blockchain platform team and started Kaleido as a enterprise platform to help customers adopt blockchain into their enterprise use cases. We started focused on initially Ethereum. Recently, we added Corda, and other popular protocols will be not far down the road for us. You can think of other popular fabrics and others to be supported on the platform in the future. Today, we're going to focus on a very interesting topic, wallets. It basically touches on all kinds of use cases and users, whether you use blockchain as a crypto investment tool, or you use blockchain as a foundational technology to do your next generation enterprise use cases. Wallet or keys is a very important component in the solution. So just a very quick refresher on what wallets are as related to blockchain. So all blockchains, so there are many blockchain protocols, both for the public side, but also for the permission side. All of them require transactions to be signed. So that's a foundational design tenet of blockchains. And to sign them, you need keys. So if you think of blockchain as a server, then wallets is a client-side component that manages your signing keys. So after you sign the transaction, it's a way to authenticate the user identity to the blockchain. So the blockchain can decide to say, I'm only going to allow certain keys or certain identities to call this particular smart contract function. So that's a way to control access and authenticate after user is authenticated. From the user's point of view, signing something means when this piece of data is transitioning from your client application, going through many components, eventually arrives at blockchain, no one can modify and hack that data along the way. Once you get something signed, you have to have the access of the original signing key to change the content that you sign over. So that's a way for the user to have immutability guarantee. So it's needless to say, it's a very important component to make blockchain work. In terms of different kinds of wallets and different kinds of keys, we have client-side wallets that tend to be the first wave of wallets that manage user keys because, as you know, blockchain really started with Bitcoin and then several years later Ethereum as public blockchain systems. In both of those cases, user keys exist mostly on the applications that support submitting transactions and transfer tokens and coins. And then later on, we start seeing server-side wallets. For example, Coinbase offered completely custodial wallets, so you don't have to worry about them. And there's pros and cons. With a client-side wallet, you have the key in your hand, whether that's a browser-based application or mobile app on your phone or desktop that you install on your laptop. You have physical access to the key yourself, and you can decide to blow it away and create a new one. Of course, you need to be very careful when you do that. So the pro is you don't have to trust any third party to manage them for you. You have exclusive access to the keys. The cons is with exclusivity comes responsibility. You have to be very careful so you don't lose them. If you lose them, then any asset that's been signed under that key will be lost. They will still be there somewhere on the chain in the chains of blocks, but no one can spend them anymore because you can't sign transactions that can make it work for you if you lost the keys. And because of this, almost all client-side wallets support some sort of key recovery, just to mitigate the case that unfortunate users will eventually lose their keys. So popular techniques include saving a key phrase somewhere outside of your app. So they basically they literally ask you to write down, don't save a digital copy, write it down and save it in the lockbox if this is meant to protect like millions of dollars of assets. Or you can use social key recovery. So in smart contract, for example, of some of the online wallets, you can set up like 3 to 4 other addresses as witnesses to your identity. So if you lost your key, you can ask them to sign a transaction and say, if they all say I'm a legitimate person, they can sign off on using a new key to replace, that sort of thing. So some of the examples of client-side wallets include Metamask, which is a browser-based wallet, and it's very developer friendly. As you are developing your web applications, it's right there in the browser to sign transactions and transfer coins. Alpha Wallet is something that we work with through a customer. One of our customer solutions is based on Alpha Wallet. And there are like at least 500 other wallets out there for different protocols. So Kaleido supports all kinds of client-side wallets as long as they support basic auth through HTTP or WebSocket. Ethereum blockchain nodes on Kaleido are protected by strong credentials through basic auth. And we expose full JSON RPC API, so you can call them through HTTP or WebSockets, and they need to be authenticated through basic auth. So any wallets that supports basic auth for HTTP and WebSocket can talk to nodes on Kaleido. We'll see a demo of this with Metamask later. Use cases for client-side wallets. If you have a consumer-facing app and you wanted to grow exponentially, so you could have endless growth of keys. So it's a good way to basically push the management of keys to the users. So you don't have to worry about that in your backend system. So it's a good way to offload the responsibility of managing, potentially billions of keys on your own system. It also has the benefit of working across chain instances because they basically exist outside of the chain. It's on the client side. It can talk to any chain that it's allowed to talk to. Ethereum has a design philosophy where they try to do everything they can to make onboarding of new users very easy. So as long as you have a key pair, you can talk to a Ethereum blockchain. Of course, with enterprise, on the enterprise side, you can choose to lock it down and say, to talk to my node, you have to have access to the node in the first place. So that's one level of control, but still you can say, as long as you have the credentials, I don't care what kind of key pairs you have, you can submit transactions. So that allows your user base to grow really easily and quickly, and using a client-side wallet makes that happen naturally. The other use case is if you have some sort of application that relies on self-sovereign data. This is also a good example to use client-side wallets to sign those data, because those data by definition need to stay on the client side, so they don't travel to other components on the back end. So to have the signing key right next to the data makes sense. So that's when you want to use client-side wallets as well. Now let's talk about server-side wallets. When you want to use server-side wallet is if your users are not very wallet savvy, so to speak. So to generate a new pair of keys, to even understand what they are, may be a pretty big cognizant threshold for some user base. For example, Coinbase decided they're not gonna let their users worry about keys at all. They manage them completely for them. The experience to use these keys is you log in to Coinbase just like you log in to Netflix, and you can ask it to sign stuff and do trades. Or in other cases, your identities are not individuals. They are managed identities in the first place. So for example, company employees, they don't really own their identities. Their employers own them. So because of this different kind of trust relationship between the employees' individual versus the employee's identity. It justifies the architectural choice to make the keys managed by the company as well, because their identity is managed by companies already. Or if you want to manage organizational identities, using a server side is pretty much a required architectural design, because you don't want any individual to be able to sign on behalf of the organization, and that key exists on somebody's phone. It's not going to pass security audit in most enterprise use cases. Or if maybe you have a use case where there are very critical kinds of transactions that must be signed by keys that are highly secured in the most secure place you can imagine. For example, hardware security module tend to be the most secure place you can place a key. Essentially, they are highly specialized devices that will never give out the keys. It'll destroy them if they censor a attempt on the keys. So these are very important for certain use cases that require keys to be managed by these specialized devices. So you have to use a server-side wallet to utilize this kind of structure. So Kaleido supports a full range of server-side wallets. The first kind is something that Kaleido built based on popular server-side wallet components. So a secure managed wallet built into Kaleido can have the keys be encrypted by user's own master encryption key. So you can provision a AWS KMS in your own cloud account. So we have, like, Kaleido has no access to that. And you use that to protect the key that's managed inside the Kaleido wallet, so that even though the key physically exists on Kaleido, actually using it requires the decryption through your cloud service. So that makes it very secure. We also have HD wallet. So that stands for hierarchical deterministic wallet. It's a special kind of wallet where you have a single key phrase that you have to remember. It's usually made up of 12 to 16 random words. So you write it down somewhere, and then from that, you can derive trillions of keys from that single key phrase. So this is a very good way to manage a huge amount of keys, but you don't have to individually keep track of them. And the good thing about this is, through the underlying key derivation algorithm, if you didn't have the seed phrase, all those keys will appear to be random. Nobody know that, key at index 1 versus key at index 2 are related somehow to each other through this common seed phrase. They would appear to be completely random. So this is very useful if you want to hide your identity. Imagine if you are a high valued individual or account that owns billions of dollars in some token or digital asset economy. If you continue to use the same key to sign your transactions, eventually your trading pattern will leak to the other participants on the chain, because they can see the transaction patterns you've signed with this particular key. Eventually, this will be leaked through trading pattern analysis, all that AI stuff. So a popular way to hide your identity and trading pattern is to use a separate key for every transaction, and they would appear to be coming from completely different random identities. So using HD Wallet to do this is good because you only need to remember one key phrase, and you can manage billions of trillions of keys. And finally, we have support to HSM-based wallet. So through popular HSM services, you can provision these HSM devices either in your own data center or in your private cloud with Azure or AWS. So the keys stay with yourself. And then you can ask Kaleido to use them to sign transactions through our remote signer service. So all the transactions will be signed through your HSM, and they are accessed by Kaleido, but the key itself will always stay in your own property. Okay, so to illustrate different ways to use these different kinds of wallet, we're going to use this demonstration scenario. So imagine you have a token economy with digital assets or a payment solution. Let's call it demo token. So somebody has to deploy it and then initially own all the coins and all the tokens. Let's call them the fund owner. So that's the owner or the investors of the fund itself. So it's a highly sensitive key that must be protected by the highest possible security system. So we want to make sure that key exists inside an HSM. And then you have under the fund owner a team of fund managers that don't own the fund, but they have the authority to transfer large amount of them. So they have very important signing keys, but not as important as the manager themselves. So we're going to use the secure wallets to secure those keys. And then let's say this is a very successful app. So you project to have 1 billion user accounts when it goes public. So you want to make sure there's a architectural, a sensible way to manage those potentially billions of keys. And HD Wallet is a great way to do that because your system only needs to manage one key phrase, and then you get yourself billions of keys. So we're going to use a HD Wallet to manage the user keys. So users are going to use them to acquire tokens, transfer tokens among them, and their keys will be managed through HD Wallet. But then you also have those different kinds of user on the right-hand side that says, I don't want to have my crypto tokens managed by a third-party component. I want to manage them myself. So we want to give them that choice as well by supporting a client-side wallet. So for this demo, we're going to use Metamask, which is represented by this lovely fox. So without further ado, let's look at the demo. So I've already provisioned a permissioned blockchain on Kaleido. It's a quorum running IBFT. So according to the best practices with IBFT, I have 4 nodes. So that's the minimum number of nodes you want for IBFT to be a robust system with fault tolerance. So now let's first deploy some token contracts. So Kaleido has a really good contract management capability. So if you go under network, so that represents your consortium. You go to shared assets and contract projects. You can create different kinds of contract projects that can manage the compilation and evolution of versions of those smart contracts for you. So you can create a contract and choose between Corda and Ethereum. And you can decide that this is going to be, the source code will be managed in my GitHub, it can be private or public. And we support both kinds, and you just point us to the link to the Solidity, and we import everything and can compile for you. Or you can say, I'm going to manage the compilation myself, so you don't have to worry about it. I'll just give you the API and the compiled bytecode. That's possible as well. So we've already done that. Let's see. I think that's in. Yeah, so that was in this project. And once you've created a project, you can create new compilations. And so this is where you point us to the source code, or you can use one of our pre-defined templates. So out of the box, we have these popular patterns for ERC20 non-fungible fungible tokens and ERC721 non-fungible tokens with mintable or burnable features. So I've already deployed that as a ERC20 with mintable and burnable. So that's already deployed. Once you've deployed them, you can then promote them to the environment. Remember, this is a shared asset across the consortium. So that's on the consortium level. To use them in your environment, what you want to do is you want to promote them to your environment. So now they get promoted from the network to your environment, and they show up here. So if you go to the environment managed resources under apps and integrations in the API gateways. So once the smart contracts get promoted into a environment, they become a REST API endpoint. And from there, you can use that to create instances of the smart contract. So deploying a smart contract is very easy. You just click that deploy instance, and then there's only one method to call, which is to deploy. And this allows you to decide which account you want to use to be the deployer, and the parameters to give to the constructor. So now let's go ahead and deploy the token contract. So I'm going to go back to the contract project, and we're going to say we're going to compile, already done the compile, then let's go ahead and deploy a different instance. Before we do that, we need to create, remember back in the slide, we want this account to be the deployer so that it owns all the tokens. And this account is going to be locked in HSM. So that let's take a look at the setup there. So what I have here is a HashiCorp Vault-based HSM, which is set up through a extension that we built for HashiCorp Vault. Okay, if you go to GitHub Kaleido.io, and if you search for Vault secrets, we have a plugin that turns a HashiCorp Vault into essentially a software-based HSM. So this is a pretty straightforward way to get yourself a HSM interface, so you can manage keys in your own data center and then have Kaleido talk to it through interfaces. So we have really detailed instructions here, as well as in our docs, that you can use to set this up. And what I have here is I've got a bunch of keys already provisioned, and you can easily create new keys like this. You can create new keys very easily through this interface. Now we've got 4 keys. So this is what you do in your own backend, within your data center or in your cloud account. Once that's all done, we need to connect Kaleido to it. So to do that, you first need to create the configuration to say, this is how I'm gonna connect from Kaleido to the endpoint that I exposed through my data center ingress configuration. So you add a Cloud HSM. Let's say this is going to be HashiCorp config. Okay, and we'll pick HashiCorp and then just filling these values. So I'm not gonna do that. So I already got this pre-filled in. So that's a configuration that talks through ngrok, tunneling to my local machine. So now I can call this through a public address. So now Kaleido has access from the Kaleido account in the cloud to this local instance that I'm running. So let's make sure it's all connected through. So remember, I just generated this new account, which starts with BAED. Let's make sure we have access to that. So after you've created the configuration, you just need to say, okay, now I'm ready to create a instance. Let's call this fund owner wallet. I'm going to create an instance that's going to use that configuration. And that's all it takes to create an instance of the HSM wallet. So now inside the wallet, let's make sure we can list out the new key. So if we refresh, now sure enough, this BAED was the new key we just created over here, and now it's listed in Kaleido. So the setup is complete. Now we have access from Kaleido to the HSM device that's running in my own data center. It's as easy as that. And of course, Kaleido is very serious about enterprise security. You may have noticed when I created the configuration, there is let me show you the details. There is information about mutual TLS, so that when Kaleido talks to your endpoint, it's not going to be hacked by man in the middle kind of attacks. So it's all protected through mutual TLS. Let's move that away so we can continue. All right, so we've got our first important wallet provision over here from the fund owner. Now let's go ahead and create another wallet for the team of fund managers. So for that, we're going to use a different kind of wallet. So we call it Kaleido's managed wallet. Fund managers. Here you have the choice of going with a secure wallet or HD wallet. It's for the moment disabled. This is only in the new console. If you want to use this for now, you have to go to the old classic console. I'll show you in a moment. But we're going to roll this out really soon. So you can use this in the awesome new UI experience. So we're going to choose this. Again, I'm not going to do that right now to save time. After you've done that, this is what you get. A wallet where you control how many accounts it should have, what each account should represent. It's really easy to add new accounts to it. So now you can add as many accounts as you have the fund managers. So let's say I've got a fund manager team of 5. So I'm gonna just add 5 accounts. And there we are. So we've got all the special managed accounts, signing accounts for the fund managers. And finally, we need a HD wallet that will manage the billions of users. To do that, I mentioned that you need to use the old console. So let's go ahead and do that. Go to the demo environment, make sure we have this. So you go to add and add a service, and then find the identity masking HD wallet. Do an add, give it a name, and add. So after you've added the service, you've got yourself a HD wallet. So let me go ahead and sign in with this. So let me go ahead and generate. It generates. Okay. Yeah. Inside the wallet service, you can add as many wallet instances as you want. But remember, every instance of the wallet already gives you at least 4 billion keys, and can be more than that, in fact. So HD wallets, each account is indexed. So like 0 will have this address and this private key, and 1 will have a completely different address and different key. So, and this index can go up to 4 billion. So that's a really good way to get ourselves a billions of user accounts. So now we're ready to start using this for something. So we're going to do some transfers. So remember, I used the, let's see, I used the HSM for the deployment. And let's go ahead and pick one of the addresses to deploy a new instance of the contract. So I'm going to use the first one. Go ahead and copy this. So that's going to be our fund owner account. So now we need to deploy a new instance of the token contract. So let's wipe this out, replace it with our highly secured account. And
one additional feature here, I've touched on this on a few previous talks, but you see that the very last parameter down there, it's called KLD register, and that will allow you to give a human-friendly naming convention to your smart contract or to your token instance. So you could put in, anything that makes sense or anything that's descriptive for this very rare token right here that Jim's creating. It's a convenient feature rather than dealing with hexadecimal addresses.
Yeah, thanks. That's a good point, Nick. So we're going to call this VRTK, or just VRTK lowercase. So let's go ahead and deploy that. So we're gonna give it only 1,000 to start with, and then all the balance will live inside the HSM device where the key exists, and that's been successfully deployed, and we have a new contract. So let's go ahead and look at the contract we just deployed. So if you go to the Data Explorer, we have this awesome Token Explorer that shows you all the tokens, contracts that's being deployed. So you can see super rare tokens already here, or actually very rare tokens. That's what we just deployed. This one, and we can see that it's got this much supply because we have 10 decimal points. And let's do some trading. So to do the transfer, what you want to do is go back down to your managed resources and find digital assets and tokens. So now this is where you can do some trading. So clicking to the address of the token and say, I'm going to start dispersing my coins from the owner of the token to my fund managers. So I'm going to first pick the HSM wallet that, which one did we pick? So we used 76E4. 76E4. This is the wallet that has all the tokens right now. Okay, so indeed, we can see the, the balance right here. So now we need to start disseminating these to the fund managers. And remember, let's say we have 1,000 plus 10. So let's go ahead and do this. We're going to divide it up into 5 parts. Just change 10 to 2. And then we're going to select our first fund manager. So that's the first. Remember, we use this ETH wallet to manage the fund manager accounts. So we're going to pick this first one, give it 2,000. Maybe I'll save some for myself. So I'll give everybody 10,000 or yeah, 1,000. So there you go. And because this is IBFT, I set the block period to 5 seconds. That's why every transaction will take a bit of time to confirm. So that was just confirmed. Let's go ahead and give it to our second fund manager. This guy, also the same amount. We're not going to do the rest of them. Just for demonstration purposes, 2 fund managers will get the coins. So now let's just make sure they've got it. So now back to the dashboard. If we pick the account for one of the fund managers, yep, indeed the token is now transferred. So this fund manager now has massive amount of tokens to manage under them. So now let's go to our users. So remember, our users are gonna have HD wallet based accounts. And because there are so many of them, they don't get displayed in this dashboard, but we can still get a peek of those accounts through the API. So let's go ahead and go to the REST API we just provisioned under this. So remember, this is the endpoint we provisioned, and let's go ahead and use the API. So the first thing we can do is let's go ahead and generate some accounts. There we go. So we know, let's say one of the users is going to use index 1, and this is the address. So let's copy that and go back to this, and then let's say, let's first try to get the balance off. And we're gonna make a call to that. And we expect this to return 0 because nothing has been transferred to this account. So now we want to transfer some values to that account. So we're going to use the transfer here, and the transfer to will be specified here. And we're going to give it, so remember, let's see, we need to get guess what? We have billions to play with. So why don't we just do a random number, just 5 zeros, 5 zeros. That's how much this user will get. And remember, it's all locked inside one of the manager accounts. So let's go ahead and get that back, which is this one. This manager has a bunch of tokens to give. So let's copy this and make this the sender. So this is the sender that's going to give some coins to this, this recipient. Let's go ahead and do it. How much time do we have, Nick?
We have about 10 minutes.
Okay.
Yeah, you're doing great. One other thing to point out, it probably goes without saying as Jim's walking through this, but there are clean REST APIs behind all of these services. So very, very easy to imagine yourself not inside of this interactive Swagger console or even inside of the pretty Kaleido dashboard, but just using your favorite modeling language and then leveraging our REST APIs.
Yeah, we have many of our customers that build beautiful user experience for their use case and use our APIs under the cover to drive things. Great, so we just validated that this HD wallet based account just acquired this bunch of tokens. So now let's go one more step. We want these users to give some tokens to another user so they can trade tokens among themselves. So you can use HD wallet based accounts not just to receive tokens, but also to send. So we're also gonna use the transfer, but because this is HD wallet based account, you need the account index to do the signing. So we're gonna use a special format string to make Kaleido be aware of the particular index in this wallet of this instance of the service. So that's it's gonna be, this is the service ID. So just bear with me a little bit. It's HD dash and then followed by the service ID. And next is the instance ID. So let me get to that. The instance ID of the wallet is, okay, may have to, I'll use that. Oh, that's annoying. Just regenerate. Okay. Yeah, this is the old instance that needs to be replaced. We're rolling out a new user experience. So that's going to come really soon. That's the, and this is going to be the ID of the instance, and make sure.
Yeah.
Yeah. E83 and
so the reason behind this syntax too that Jim is showing is you could actually have multiple HD wallets within your service. So there is a necessity to actually specify not only the service ID but the wallet ID as well, and then obviously the index here.
Yeah, thanks, Nick. So I'm going to transfer from account behind index 1 to the account, another lucky user behind index 100. So I use the service to get the address, and now I'm ready to transfer. So this is gonna be 1/10 of what I have to this address. Okay. So this is now asking Kaleido to use HD wallet to sign a transaction that'll transfer a coupon, not a coupon, a token to another address. So now let's just validate that the new account has acquired the token. Yeah, indeed. That's 1/10 of what index 1 has. So you can see it's very easy because Kaleido has built the integration between the API and the wallets, and all kinds of wallets, HD wallet, ETH wallet, and HSM-based wallets, and the blockchain itself, so that as long as you provide the proper address, Kaleido can look them up regardless of where which wallet instance and which type of wallet the address exists, find it, use it to sign it, and then send the transaction to blockchain. So that's all automated behind this awesome RESTful interface. And of course, if you want to do things yourself the traditional way, using raw JSON RPC with Web3, each wallet gives you access to direct APIs, so you can query for the addresses they contain, ask them to sign a transaction for you, and then you can take the raw transaction signed by the wallet, submit it to the blockchain node yourself. You can do that yourself with Web3, no problem. Okay, so we demonstrate everything except for Metamask. So we have integration with Metamask as long as you specify the correct configuration for the network. So remember, each network is protected by credentials. So you just take the full URL from your blockchain node. So if you go to the node, the URL is supplied over here. When you click Connect App, it'll generate the app credentials and give you the full URL that you will then plug into here, into Metamask, and say, I'm going to talk to not the mainnet, but a special network, and you specify the URL here. So that's what I did for this network that's showing up right now. It's the Tech Tuesday that is pointing to this instance right here. So you can see that this account has some tokens already, but this is the token, this is not the right token. So we need to tell Metamask what the right token is. So we're going to get the address of that token from here. So that's our new token address. And we're configuring Metamask to be aware of this new token. And you see it's making Web3 calls under the cover and already discovered that this is called VRTK, and this got 10 precision decimal points. So we're gonna go ahead and add some tokens. And this account at the moment has no tokens. So let's go ahead and submit some transactions to this account. So we're going to copy the address of this account and go back to our, let's go ahead and use the dashboard for this transfer. So again, I'm going to have the font manager. So this is the font, this is one of the font manager accounts. Transfer, let's say this many. We'll give it more because they are they're using client-side wallets. We treat them specially. So that's the target address maintained by Metamask. Do a transfer. Wait for the transaction to be confirmed. Let's check. All right, so this is the token we've got. Still 0. Let's see, do we have the right 667? That's the address. And that's the very rare token. Okay. Oh, there we go. So it just got the token, and the balance is now updated. Yeah, so let's see if we can actually send some of this token to another address. So this is using Metamask to sign a transaction and send it to, to a different address. So let's see, what other addresses do we have? Maybe we'll go ahead and use this user. We'll go ahead and use this user. This is one of the users based on HT Wallet. So we'll go ahead and send some of our MetaMask-based tokens to that address. We're going to send 0.0001. Let's make it very fast. Confirm. Yeah, I think this is because a MetaMask is probably needs to be configured to use zero gas, is what I'm guessing. I didn't practice this beforehand, so I didn't set up MetaMask to be able to send. But you can see you should be able to send tokens from MetaMask directly, signing it, and then send it to the blockchain. So we don't really have time to debug into that, but that was the last step anyway. So that's.
So we have an Ether pool on Kaleido too, where basically you just go ahead and fund your MetaMask private account with some Ether, and then it'll be able to, you know, imagine that it's deploying to, you know, a public network and using actual gas costs. It's just an arbitrary construct in Kaleido needed for EVM execution with certain plugins like MetaMask, for example.
Cool. So just to review, Kaleido supports all these different kinds of wallets that are browser-based, as well as client wallets that support standard JSON RPC interfaces. So regardless of what your scenario is, if your blockchain is based on Kaleido, you can use Kaleido for all kinds of different types of way to manage your keys. And that was the end of my part. Back to you.
That was great, Jim. I really appreciate the well thought out demo scenario there. Hopefully that was useful to folks to see the flexible employment of different wallet management and even the cloud HSM for those highly secured private keys and addresses. For everyone, super big thank you everyone for attending. Just some kind of foreshadowing, next week we'll be joined by another one of the co-founders of Kaleido, our head of engineering, and he's going to take everyone through Kaleido private stack deployments. So we'll show you how to run a fully managed node in your own on-premise data center on your own machine, or in a private cloud orchestration. So that'll be super enlightening. There is a quick question from George around, is there a way to capture the respective REST API calls that Jim was walking through inside of the console? So I'll give you two answers to that. There is a very clean service API for every token interaction. So if you just go to api.kaleido.io, you'll see two tranches of APIs: administrative APIs, where you can create resources, delete them, cycle credentials, etc. And then we have our service APIs, which you would actually program against when you're leveraging document stores or token factories. And all of those clean endpoints he was showing, mint, transfer, burn, add, custodian, etc. Those are all exposed right there. The other thing too that may have gotten slightly lost in context was what Jim was doing too was really just interacting with a single smart contract instance, that VRTK, very rare token smart contract that he created. And basically just using our REST API gateway with a little Swagger client inside of your server-side application, you can do all of those same calls, all of the same transfer calls and everything that's exposed inside of the token smart contract. So really simple to program against here. And the API documentation is very thorough. And kind of well documented as well inside with all of the dev docs and all of the calls and parameters that are available. It's a good question, George. So thanks for that, Jim, pulling that up. Well, that was awesome. We got the full hour. Like I said, I threw my email in the chat if anyone has any technical or commercial questions. There's also a contact us feature inside of the console if you want to open up bugs or support tickets or request a commercial or a technical meeting as well. That's a great way to reach us. So don't hesitate to reach out directly to me or through the console. And again, thanks everyone for attending. This is recorded. It'll be shared with you. And please do join us next Tuesday to check out Kaleido Private Stack. It's really, really cool. So thanks again, and big thanks to Jim as well today.